Hello, let's talk about the validation system. So this is an optional system that's part of the generation process. Its purpose is to iteratively rebuild the volume with tweaked settings to create the perfect output. You specify what your threshold for good is, and it will progressively make more and more aggressive changes trying to create a volume that meets your requirements. Let's have a quick look at this volume here. So if we regenerate it, we can see there's all these warnings that are showing up here, and this is because the volume is coarse enough that some sections are not encapsulated by the volume. Now, all we simply have to do is enable the validation system, and then when we regenerate it again, we can see that it created multiple shapes trying to fix those warnings that were there, and then it finally created one that passed through validation checks on the 10th attempt. And so now it has 0 warnings and errors. And if we want to track exactly what it's doing, we can open the full log, and if I run it again, we can see exactly what it did here. But let's take a look into what the actual system does. Okay, let's talk settings. So anywhere that you can use the validation system, you will see validation settings. So if we open this up, we see our first 2 settings here. So the warning and error thresholds determine what our target is for the validation system. So if you've seen the test video, you'll know that a warning is a point that was detected on geometry that isn't covered by the volume, and an error is a location in the interior space, not colliding with anything, that isn't covered by the volume. So errors are much worse than warnings. Warnings may not be a problem. It really depends on your use case and where they are. But errors usually are a problem because they are open space areas that should be covered by the volume that aren't. So these are the values that the system is trying to reach or better. So in this case, the validation system is trying to build a volume that has 5 warnings or better and no errors at all. And it will keep doing this until it creates that volume, or it reaches the max number of attempts here. So let's build this volume here, and we can see that it's got these warnings that have showed up here. We have a total of 13 warnings. So if I enable the validation system and then regenerate again, okay, now it's passed validation. Yay, it did it on attempt 10, and it's created a volume that just managed to hit it. Now, it could have been that it actually came below 5. It just so happened that this one came in at 5 and 0, which was exactly what our threshold was. So let's try lowering it down to no warnings. So we don't want any issues whatsoever, and we want these to be gone as well. So let's regenerate. Now in this case, it's failed validation. So it wasn't able to create a volume in the 12 attempts that it had. So it went back and rebuilt the best attempt, which was attempt 10, and that had 5 warnings and 0 errors. It's the same one from previously. So why don't we increase the maximum attempt number? So let's crank this all the way up to 30. Or, I mean, if you want to, you can actually type in higher values. If you didn't know that, in most of the settings here, you can actually type in higher values. But let's stick with the maximum slider amount, which is 30. I'm going to regenerate. You can see it does it pretty quickly. And again, it wasn't quite able to do it, but it made one with 2 warnings and 0 errors on attempt 28, and it's used that. Let's try it at 50. And it did it. Finally, it was able to do it on attempt number 32, and it created a volume with 0 warnings and 0 errors. Totally nailed it. Perfect. So let's talk about strategies now. This is the method that the validation system is going to use to try to improve the volume. We have a whole bunch of different options here, but let's start with expand entire volume. Now, this one's pretty obvious. This is the simplest one to understand. So effectively, what this does is it's going to increase the expand amount until it reaches a point where it encapsulates the volume. So these are, of course, great for times where the volume's not quite big enough, or just by enlarging the volume, it's going to fit the space better. It's akin to pressing this button here a few times until the warnings go down. So you can see currently it's on 9 warnings, and as we increase it, 8, 7, 6, 5, 4, and you see how it works. We can see the shape here changing and increasing in size. If we want to see that even better, we can show selected. Let's reset the size and increase. And one by one, you can see the warnings disappear. So that's effectively what the validation system does in this mode. And it will repeatedly increase the expand size until the warnings have hit your threshold. So if I enable validation and then regenerate, now it's made a volume with only 5 warnings. If I wanted to, I could lower this. It's had to increase it quite a lot, but you can see there that it's managed to do it. Now, the great thing about this mode is that it more or less keeps the shape intact. So it hasn't sort of enlarged it in one area and not in others. Generally, it's kept the shape. And so it's fairly safe, but of course the downside is that it's enlarging areas which don't need to be enlarged in order to fix the problem. So if you have one problem here, it's going to enlarge the whole thing. And so it's not targeted. The next one is the opposite of that. It's targeting enlargement. So in this case, in expand warning areas, as the name suggests, it will enlarge areas where the warnings are happening. So this one, for example, will get pushed out. It can do a really good job of fixing specific problems in certain areas. Like this spot here is obviously a really focal point for errors. And so it's going to just focus its efforts to this bit. And you can see that it's enlarged this area and this bit here and here, but it's kept this bit relatively intact. So if we compare that to the original, it's actually not touched this section at all, but it has changed these bits. Now, this is very powerful, this mode, because it will ensure that these sections are fixed without messing with anything else. For example, if these sections here are a glass wall or something like that, where you really don't want it adjusted, this would be a really good solution to use. The downside to it, of course, is that it doesn't retain the shape. And if it's really struggling to fix the problems, it's going to push the volume into a really odd shape that might actually cause problems. So it could bleed the volume into other areas and change the shape of it, but it is really good for small targeted fixes. Here's a really good example of the expand warning area strategy working its magic. If I just show this volume here, we can see we've got some warnings and errors here and some warnings here, but the rest of the volume is perfect. And so if I just enable validation on it with the right strategy, I've got my warnings and errors down to 0, 0, and we're going to regenerate, and we'll see it iteratively build the volume, and you'll see the warnings one by one disappear. And there, it's fixed it. Of course, as I've mentioned before, it has changed the shape, and in order to fix it, it's had to push this one face out quite far, and that's caused it to get a bit bulbous over here. This is quite an extreme example here, but you can see how it works, the benefits, but also the potential side effects when it goes too far. Next up, we have two resolution-based strategies. So resolution adder will iteratively add or subtract small amounts to the resolution setting, and resolution multiplier will add or subtract percentages, typically much larger amounts. And so one is meant to sort of nudge the values a little bit at a time, whereas resolution multiplier will change large amounts, and it scales well with larger resolution settings. So if you're dealing with a really big space, it will work really well with that. In this case here, we've got a small and very detailed cylinder. And if we just regenerate, you can see that we have 9 warnings here. And with the resolution adder strategy, we enable validation, and it's managed to find a resolution setting that resulted in 0 warnings and 0 errors. So this is great. You can tell what the actual picked resolution was here, 3, 4, 6. It was actually close to where we were originally. And if you want to push the settings that were used to make the final validated volume to the widget, you can just recall after having made it. And now our setting is here. So now I can actually disable validation and just hit regenerate. And because the validated volume pushed its settings to the widget, we have parity between the volume and the Volumator settings. In this next example here, we have a much larger space, and it's resulting in these warnings here. And if we would just use the resolution adder as our strategy, regenerate, it's not going to do a good job because it needs a bigger change to the resolution. We've used a much larger resolution amount here because it's a larger space and we want it to be really quite coarse. But if we change the strategy to resolution multiplier and then regenerate, it fixed it after the first iteration. And that's because it's working with much larger amounts and because it's multiplying it. And so if you're dealing with larger resolution values like this, it will scale better and just typically find a better solution. So it's worth trying both, but it really depends. If you're dealing with larger resolution amounts, it's worth trying the multiplier. But it depends how far off the perfect resolution amount is. As next one, voxels on issues will take our warnings and errors and place voxels on them. So it's kind of like a mix between perimeter mode and voxel mode, but using the validation system to place the voxels. So in our example here, we have a few warnings here and here, and some of them are quite difficult to fix. This jumps to the wrong wall here, and whereas this is on a curved edge here. In this mode, it's going to place a voxel here and a voxel here. Let's see how that works. And you can see quite clearly the outline of a voxel here and one here. And so obviously it's drastically changed the shape in these areas, but it's guaranteed absolutely 0 warnings and errors. And it only ever does one attempt because it only needs to. Once it's placed a voxel over that, it's ensured that the warnings and errors that were detected are covered in the volume. So the positive side of this one is that you can be ensured that your volume covers the space without doubt. The downside, of course, is that the shape is not at all matching the room perfectly. And it's the likelihood that it's increasing the triangle count as well because it's added extra shapes to it. But it has dealt with the warnings and issues really well. So it's a potentially useful system, especially in a more angular environment. Trial strategies, as the name suggests, will go through each of the strategies one by one and then cycle back to the beginning, go through them again. And each time it does a round of strategies, it will increase the aggressiveness until it gets there. So the upside is that if you don't know what the problem is and what the best strategy to use is, this one is a bit of a no-brainer and it will figure it out for you. The downside, of course, is that because it's trying all the different strategies, it requires more attempts than if you just pick the correct strategy to begin with. So inevitably, you end up having to crank the max attempts up, and it will take slightly longer, but the great thing is you'll end up increasing your chances of getting a good result. So in this case here, we have a few issues here, and let's enable validation. We're going to make sure that our warning threshold is down to 0, so we don't want any problems here. And off it goes. And as expected, it didn't pass validation because it requires more attempts. But it did build one with only 2 warnings. We could pick that if we wanted to. It was build number 4. And in fact, let's open up the full log and you can see exactly what it was. So validation attempt 4 was expanding the entire volume. So you can track there exactly what's happening and which one is proving to be the best. But let's crank this all the way up to 50 and we'll see if we can do it with that many. That should be possible. And there we go. It did it on attempt 37. And here's our volume. I don't even have to check, actually. I can see that it's expanded it there, and that's what's ended up being the right one. Here's a good example of where validation and the trial strategies can work really well. So we've got a weird volume here where it's obviously got some problems during detection. In many cases, it's best to just redetect the area. But if we just look at what happens here, if we keep tweaking the resolution setting, we can see that it's just got some weird stuff going on, getting some really odd results here. But if I just simply enable validation, crank the max attempts up on trial strategies, it will eventually find a good result. There you go. It didn't even take very long. And so this can be really helpful in cases where you just want good volumes and you don't want to mess around with stuff. So this is why by default, the settings are validation on and trial strategies. So far I've been talking about how the validation system works in perimeter mode. But if you're in voxel mode, it works slightly differently. And that's because in voxel mode, you will never get any warnings or errors. And so the system has nothing to work with to improve the volume. But instead, the main way that we can improve voxel performance is to reduce the number of voxels. And that way we'll be reducing the number of triangles and the complexity of the volume. So the way that the validation system works in voxel mode is it will build all of the attempts that you allow it to, and it will iteratively tweak the size of the voxels, and then it will check how many voxels it's used to create the volume. So let me give you an example here. We have a volume here that's created resolution 300. If I enable validation, you can see that it went through all 12 iterations, and then it changed the volume to one that's actually slightly larger voxel size. It's actually a resolution of 336. But because of the way that the voxels lined up, it used slightly less voxels. So this is a total of 78 voxels. And if I reset it back to what it was previously, it's up to 99 voxels. So using the validation system, it will try to optimize the voxels to suit the shape. So that's the validation system. It can automate the process of finding the right settings to make the perfect volume.